All right, the last example I'm going to do involves finding roots. And so this one here says find all fourth roots of this complex number, negative 8 root 3 plus 8i. So again, with de Moivre's theorem, the roots version of it, we need to know the radius again, and we need to know the angle, r and theta. So r is first. It's the square root of the sum of the squares. Now, the square of the first term is 64 times 3, right? You square the 8 and you square the root 3. The square of 8 on the second term is 64. Again, both are positive because you square the negative, you get positive. If I work this out, if you think about this, I could just evaluate 64 times 3 plus 64, but think about this as there's 3 64s plus another 64, that's 4 64s. Because I know 4 and 64 are both square roots, I could just write it this way and then break down each root. Square root of 4 is 2, square root of 64 is 8, that's a 16 radius, okay? And if I just evaluated this, take the square root, this would be, 256, and then the square root is 16 also. So either way, then theta is going to be the inverse tangent of b over a, so it'd be 8 over negative 8 root 3. Well, the negative, or the 8's cancel, we got a negative in there, so it's the inverse tangent of negative 1 over root 3. If you were to toss that in your calculator, negative 1 over root 3, it's going to be a negative 30-degree angle. All right, here's where we've got a little bit of a problem, because the original point is in the, let's see, it's a negative real, positive imaginary, so it's in the second quadrant, whereas this is a fourth quadrant angle. So just a quick sketch, this point's got to be up, well, let's see, this angle is down here, so that point is on the same angle but in the second quadrant, corresponding second quadrant angle. If this is 30 degrees, then I need to come 30 degrees up from 180, which is 150. So that would give me a 150 degree angle for theta. Okay, that would be the equivalent in the second quadrant. So to find the roots, remember the nth root is going to be the nth root of r times the cosine of alpha plus I sine of alpha, where alpha is equal to theta plus k times 360 all over 4 in this case, because we're looking at fourth root, so the n here is 4. And k has to run, well, there's got to be 4 of them, so it's 0, 1, 2, and 3. Okay, so k equals 0, 1, 2, and 3. So we just calculate this for those 4 values of k, and we'll have our 4 roots. So the first one has a k value of 0. Theta then is equal to 150 over 4. 150 over 4 is 75 over 4 is 37.5. Let me double check. 150 divided by 4, 37.5. So it's a 37.5 degree angle. If k equals 1, then theta is 150 plus 360 all over 4. 150 plus 360 divided by 4 is 127.5. Okay, and then when k is 2, theta is 150 plus 720 over 4. So we just punch that in, 150 plus 720 divided by 4 is 217.5. And then when the k value is 3, theta is 150 plus, what's 3 times 360? 1080. So this would be 1080 over 4. So 1080 plus 150 divided by 4 is 307.5 degrees. Okay, so those are our 1, 2, 3, 4 angles. And then the corresponding value here, well, what's the fourth root? I should probably calculate fourth root of r. Well, the fourth root of r, take it up here, is fourth root of 16, which is 2, right? So overall, I'm looking at 2 times the cosine of 37.5 plus I sine 37.5. And then I'm just going to have to calculate that stuff. So 2 times the cosine of 37.5 is approximately, now these are approximations and I am going to be rounding. I don't know, your textbook doesn't really give a place to round. You know, if you need to round, then on my math lab it'll say where. Most likely on my math lab these will come out nicely so that you can give exact values using your special triangles, but it may not always do that. So just be aware of where to round. I'm going to round to 4 decimal places, so this is 1.5867 plus I, and then I need 2 times the sine of 37.5, and that's going to be approximately 1 point, well, I'll do the I at the end, so it's plus 1.2175I, right? So that's one of the roots. Another root is going to be, it's basically the same thing. I'm not going to rewrite all this stuff, but it's basically the same thing. I'm just using the new angle in there. So it's going to be 2 times the cosine of 127.5. And so that is negative 1.2175. And then I'm going to put the sine. So 2 sine of 127.5 is 1.5867I. All right, looking good. Now I do the same thing with the 217.5. So 2 times the cosine of 217.5. That is going to be negative 1.5867. I'm guessing it's the same 2 values over and over again. That would probably equally space these around the circle. And I think the signs will change, which is what gets it into each quadrant. So, but I'm going to verify it on here anyway. I'm guessing this is a negative of the 1.2175. As it is. So minus 1.2175I. And then the next one will probably have a positive and a negative with the values in that order. We'll see. I'll punch them in just to make sure. So I get 2 cosine of 307.5, which would be positive 1.2175. And I'm guessing it's going to be minus 1.5867I if I'm just following the pattern. Let's verify that though. 2 sine of 307.5, and for sure that is it. Okay, so those are going to be the 4 fourth roots of this number, negative 8 root 3 plus 8I. All right, and so again, the main things to remember when doing the fourth roots, or any roots, doesn't matter which ones, you're going to take, you have to find the radius and the theta, make sure the theta is in the proper quadrant, take the nth root of the radius, and then figuring out the angle from theta is probably the hardest part. So you take the angle, divide it by n, whatever n is, then you add a 360 and divide by n, then add another 360 and divide by n, and then add another 360 and divide by n. And you do that until you have the same number of angles as you have the root here. So if I'm looking for the fourth root, I want 4 angles, okay? And that gives me the 4 different fourth roots. Now of course you start at 0, so you should always end one less than the number on the root, okay? And then when we plug all that stuff in, you'll end up with new complex numbers. In fact, here these are 4 complex numbers, and again they are equally spaced on a radius of 2 around the origin.